Dear students, first unit 1 Introduction to Computers. Question is explain about hardware components or explain about block diagram of computer. Computer is a machine that works with the instructions given by the user. A computer is made up of two major components. One is called hardware, second one is called software. Computer hardware. Computer hardware means the physical things which we can see and touch is called hardware. The different hardware components are input devices, motherboard, main memory, etc. See here main memory, input devices, keyboard or mouse is called input device, output devices, monitor or printer is called output devices. Now motherboard. Mainly motherboard consists of two things. One is called main memory, that is RAM. Second one is called central processing unit, CPU. It is also called microprocessor. Now outside motherboard it is going to be connected to secondary storage, that is hard disk. So main memory is connected to hard disk, main memory is connected to CPU. Now first one is input devices. User given some data to the system is called input. Input is given by using different input devices. Different input devices are keyboard, mouse, etc. Motherboard. It contains CPU, main memory and connects different hardware components such as hard disk, CD, DVD, keyboard, mouse, etc. Third one is main memory or RAM. Main memory means storage. Main memory is also called primary memory. In main memory we store data temporarily. Normally main memory is RAM, that is random access memory. When the computer is shut down, everything in RAM is deleted. Fourth one is CPU. CPU is also called central processing unit or microprocessor. It is the brain of the computer where different operations taken place. It consists of the following: A. Control unit CU. It controls the hardware component of a computer. It is responsible for processing data. This CU is called as a control unit. Next, ALU, arithmetic logic unit, ALU. Different operations of the data are carried in ALU. For example, to do addition, we send data to the memory. The memory gets data from the CPU gets data from memory and process the addition in ALU. After that, it send the result to the main memory. Now the main memory send the result to the output for display. Registers. In processing, CPU use registers to store data and intermediate results. To store data and intermediate results, CPU can use the registers. Next, secondary storage device. Secondary storage device is also called secondary memory. Secondary storage devices are used to store large amount of data permanently. Examples for secondary storage devices are hard disk, CD, DVD, etc. Output devices. Systems send output to the user using output devices. Second one, explain about computer software. The software is set of programs and program is set of instructions. The different types of softwares are: number one, system software; second one, application software. Again, system software. What is system software? The software which interact with computer hardware is called system software. Best example is operating system. Now, what is operating system? An operating system operates and control the hardware and provides to work with application software. Most of the operating system is written using C language. System support software. It provides system utilities and disk format programs, and it protects system and data. System development software. This software is a language translator. That means it converts program into machine language. Second one, application software. The software which interact with the operating system and help for user is called application software. For example, MS Word, Excel, PowerPoint are application software. In this A general purpose, it is general purpose software which is called word processor. B application specific, it is used only for a particular task. General ledger system used by accountant is called application specific software. Discuss about computing environment. Computing environment is a computer or collection of computers that support processing and exchange information for various types of computing solutions. In this first one is personal computing environment. In personal computing environment, a personal computer is operated directly by a user. Personal computers run on Windows or Linux operating system. is nothing but the personal computer, monitor, keyboard, mouse, CPU, and switch and DVD. Time sharing environment, second one. Employees in large companies work in time sharing environment. In time sharing environment, many users are connected to one or more computers. Many users are connected to one or more computers. The central computer manages the shared data and printing, it must do the computing. And printing, it also going to be make the printing also by sending to shared printers. Then client server environment. In client server environment, split the computing function between a central computer which is called server and user computer which is called clients. These are the user computer, the server. Server is connected to central storage, server is also connected to shared printers. Client always communicate with server and work is shared between client and server. Distributing environment. A distributed computing environment provides integration of computing functions between different servers and clients. The internet provides connectivity to different servers throughout the world. This internet connectivity different servers, server 1, server 2, like that. Server 1 is connected to storage 1, the server is connected to storage 2, and this internet is also, the computers is clients also connected to client internet. What are different computer languages explained? To write a program, we use a computer language. Over the years, computer languages have evolved from machine language to natural languages. A summary of computer languages is shown in the following figure. Machine language in 1940s, symbolic languages in 1950s, high-level languages after 1960s. Number one, machine language. It is first generation language. It is also called. Here we use the high volt, 5 volt is 1 and low volt, 0 volt is 0. Thus, an instruction may be represented as sequence of zeros and ones. So, the programs may be represented as sequence of zeros and ones. The instructions written in machine language are easily understood by the microprocessor because they are writing directly zeros and ones. But for programmer, it is very difficult to write these programs because we should remember many zeros and ones. It is also very difficult to locate errors and correct the program. Second one, assembly language. It is second generation language. These programs are written using symbols. That is also called mnemonic code instead of machine code. So this language is also called symbolic language. All instructions of assembly language are written in capital letters. For example, the symbol sub stands for subtraction, add stands for addition, etc. So writing programs for programmer is easy for compared to machine language. But the instructions written in assembly language are not understandable by the computer. So assembler is used to convert assembly language into machine language. Assembly language, assembler convert into machine language. Therefore, the execution time of assembly language program is less compared to high-level language programs. Low-level language, high-level language. What is this? Low-level language. Low-level language is a programming language that deals with the computer hardware components. Machine language and assembly language are popular examples of low-level languages. Learning low-level languages are difficult for programmers. High-level language. It is third generation language. These languages consist of keywords or syntaxes which are easily understandable. Writing a high-level language program is easy compared to machine and assembly language programs, but the programs written in high language are not understandable by computers. So, compiler is used to convert the high-level language into machine language. High-level language into machine language. Examples of high-level languages are C, C++, Java, etc. Therefore, the execution time of a high-level language program is more compared to machine and assembly language programs. Next, procedural-oriented language. Procedural-oriented language is a language which consists of writing programs using functions or procedures. Example, C language. First, we define procedures or functions and then call these. Each procedure or set of procedures put together are called models. The main program is divided into procedural models. This development also allows large programs, but it presents many difficulties. So another type of programs are developed, which are called object-oriented programs. Now, object-oriented programming languages. The object-oriented programming language consists of objects and classes. Object is an instance of a class and class contains number of objects. The objects inside a class can share same structural behavior of a class. A class is defined variables and methods, which can handle both classes and methods. If a class handle that is called static and if object handle is called instance. The data is used in methods. The characteristics of a code are given by data abstraction, encapsulation, inheritance, and polymorphism. How to create and run programs explained with example. It consists of our following steps. First, error. First, there is a source file. There is a source file. Now, the compiler, okay, if it gives success, then creates object file. Otherwise, this compiler gives any error. The program comes any error, then it gives error message, which is called unsuccess. Then the object file, which is format is binary. The linker, there is a linker. Linker is going to be link about the this object file, and also writing about hash include some statement on at the top of the program, hash include stdio.h. So that code and whatever your program object code, both are going to be combined by using the linker, and it creates executable file. Now there is a loader. Loader, what it will do means it will bring the whatever the program going to be contains. C program contains about the input or output. Sorry, input both can bring it. Okay, this loader. So what the loader will do about the displaying the output, simple words, displaying the output. Loader is made responsible for loading the executable code in memory, so that if you give input you get the output in simple terms. Creating a source file, which is called a program which is written high level language, is called source file. So first source file, creating a computer source file first off. We converting into object file. Compiler converts high level language program to machine language is object file. The source program is compiled create object file linking. The linker combines object files and create an executable file. This executable machine for loading. Loader copies executable file to main memory and execute. The example program, simple program, we are taking ABR. Enter AB values in A and A and come and B. Now R equal to A plus B. Okay, that is nothing but the addition. The sum is given by comma R. Here we write the percentage D value. The sum is value. Okay, the sum is we are getting about the value. Thank you. Now explain about software development process. The software development process consists of problem requirements. Problem requirements means specify the problem requirements by knowing the problem clearly and understanding its solution clearly. Second one, analysis. It consists of knowing input, output, and any additional requirements for solution. Design. Design an algorithm by developing the following steps. 3. Get the data. 2. Computation. Display the results. Implementation. Writing programs to the algorithm. It is called implementation. Testing. It is checking whether the completed program works correctly or not. For this, we need to develop test cases. Maintenance. When maintenance starts, error occurs, so remove errors and update the program. What are the different number systems that are used in computers? Explain with an example. The number systems that are frequently used in computers are binary number system, that is 0 and 1. If any given 10101 to base 2, then how you can write this at the end? Last one is 1 into 2 power 0 plus 0 into 2 power 1 plus 1 into 2 power square, 0 into 2 cube, 1 into 2 power 4. So 1 into 2 power 4, 0 into 2 cube plus 1 into 2 square plus 0 into 2 power 1 plus 1 into 2 power 0. So finally get about 21 to base 10. Octal number system, that means octal digits are 0 to 7. So 8 number system, for to convert this 8 number system, first in 8 power 4, because 0, 1, 2, 3, 4. 1 is nothing but fourth place, 2 is nothing but third place, 5 is nothing but second place, 7 is nothing but first place, 0 is nothing but 0 place. So that's why 1 into 8 power 4 plus 1, 2 into 8 cube, 2 into 8 cube plus 5 into 8 square plus 7 into 8 power 4, 1 plus 0 into 8 power 0. So finally get 5, 4, 9, 6, 10. Hexadecimal number system. Hexadecimal number system, it uses 10 digits and 6 letters. 10 digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 6 letters are A, B, C, D, E, F. A equal to 10, B equal to 11, C equal to 12, D equal to 13, E equal to 14, F equal to 15. So A, B, C, D, E, F either small letters or capital letters, both are correct. For example, if the hexadecimal number is 19 FDE to base 16. So 1 into 16 power, E is 0, D is 1, F is 2, 9 is 3, 1 is 4. That's why 16 power 4 plus 9 into 16 cube, then F into 16 square, D into 16 power 1, E into 16 power 0. Now 16 power 4, 9 into 16 cube, 15 into F means 15, D means 13, E means 14, replace, and finally get the value is 10, 64, 62 towards 10. How to store integers in computer? Explain in simple terms. Unsigned integers. First, here the number is changed to the corresponding binary form. That means the number divided by 2, whatever the remainder you are getting, consider that remainder and store it as this. For example, an unsigned integer can be stored as number from 0 to 15 in a 4-bit integer I have taken. How to store 0 to 15 as a positive number? 0 means I'm taking 4 digits, 4 or 0. 7 means 0, 1, 1. If you divide 2, the remainders, whatever you are getting about this one. 8, if you divide 2 by 2, you are getting 1, 0, 0. 15, 1, 1, 1. Now, signed integers. The problem is here, we must consider both positive and negative numbers. That is the case. There are different methods to store signed integers in a computer. They are sign and magnitude, one's complement, two's complement. Sign and magnitude. Here we consider the leftmost bit to represent the sign of the number and the rest of the bit to be as it is positive number. So here we consider the leftmost bit to represent the sign. Leftmost bit contains the sign. So that means the leftmost bit contains the sign of the number 0 for positive, 1 for negative. 0 for positive, 1 for negative. Addition subtraction are very inefficient operations. 0 for positive and 1 for negative. So 0 becomes minus 0 means here it is 1, that is negative. Here 0 positive means here it is 1, which is nothing but the negative. Remaining is as it is. Okay. Now one's complement. One's complement we use the complement operator to find not A from A shown in the following figure. Here plus 0 minus 0. So all zeros are converted into ones. Then next plus 3 minus 3. So 0 0 becomes 1 1, 1 1 becomes 0 0. Then plus 7. 0 becomes 1 and all three ones becomes 3 zeros. Addition and subtraction are very simple operations here. To add a plus b, we just add the numbers bit by bit. To subtract a minus b, we just add a and complement of b, that means a minus b equal to a plus of minus b. Now add plus 3 plus 4 plus 7 plus 3 in binary form 0 0 1 1. 4 in binary form 0 1 0 0. 1 plus 0 1, 1 plus 0 1, 0 1 1, 0 0 0. This is the answer. Now plus 3 minus 4 means minus 4. So how we can write the minus 4? So minus 4. So we have to subtract here. So we made making about the subtraction. Subtraction is we are getting minus 1. How it is possible? You take first plus 3 0 0 1 1. Next plus 4 means minus of plus 4 means take about the minus 4. 4 is how much? 0 1 1 0 1 0 1 0 0. Minus 4 means reverse 1 0 1 1 adding. Now 1 1 0 carry over 1 1 1 0 carry over 1 then 0 1 1 1 0 1 0 1 1 1 1 1 0 is the answer. Two's complement. In two's complement, first we use the complement operator to find not A from A. Next add 1 as shown in the following figure. Say for example, plus 3 minus 3. What is plus 3? 0 0 1 1 0 0. If you add 1, how much? 1 1 0 1. Now you take 0 1 1 1. Minus 7. Minus 7 means 1 triple 3 zeros. 1 3 zeros. Okay, normally. But at the end, what you can write? You write 1. That means how much? 1 0 0 1. Addition and subtraction are very simple operations. To add a plus b, we just add numbers bit by bit. To subtract a minus b, we just add a and the complement of b. In other words, a minus b equal to a plus of minus b. See here, plus 3 plus 2. Plus 3 plus 2. How much? Plus 5. Then 0 0 1 1 0 0 1 1 1 0 1 1 1 0. Then carry over 1 1 0 1 1 0 1. Then 0. Then plus 3 minus 2. Minus 2 means this 0 0 1 0 becomes 1101 actually 1101, but if you add at the end 1, it becomes about the 1110. Now add both 101 1101 110 1101 110. Okay, this is nothing but the answer. Now how to store real numbers in computer? Explain. Real numbers are stored by binary number. For example, consider a equal 34.125. When we convert 34.125 in binary, it is for 34 how much? 100010. But 0.125 how you can convert into 001? That is first 0.125 into 2, then 0.25. This is here it is 0. Then 0.25 into 2, 0.5. Here it is 0. Now 0.25 into 2, 0.5. into 2, 0.5 into 2, that is nothing but the 1. That means what are the different values here? 1 is there, 0 is there, 0 is there. You can put a 0, 0, 1. So the 0, 0, 1 you can put here. Finally, I want to move this point to 1.0 like that here. So how many places I can change? Here it is 1, here it is 1, 2, here it is 3, 4 and 5. So that's why 1.00 something into 2 power 5. The decimal point is moved left position, 5 position. Now as per the standard, 1 will be removed. So remove 1. So what is your get? 0, 0, 0, 1, 0, 0, 1. Going to be repeated. And this is called as a mantissa. Now here 2 power 5. 2 power 5 means what is there? 5 is there. So if you divide this 5, you are getting about 101. Okay, that is convert 5 into binary format, you are getting 101, which is called exponent. Now let us see how to construct a 32-bit binary using these values. Means 1 bit represents sign bit, 8 bits represent exponent, 23 bits represent mantissa. In this case, the number is positive, so sign bit is nothing but 0. In this case, the exponent is 5, but 5 is not minimum because 127 only you are getting. Okay, sorry. 5 means you are getting only 101, but it is not sufficient. So because of that reasons, we add about 127 to 5. You are getting 132. Now divide 132, that is convert into binary format, 1, 4 zeros, 100. Now in this case, the mantissa that equal to how much value? You take the mantissa. Mantissa is nothing but triple zeros, 1, triple zero, 1. Triple zeros, 1, triple zero, 1. After that you put 0, 0, 0. Because you need about the mantissa how much? 23 bits. So here how many bits are there? 3, 4, 5, 6, 7, 8 is there. So 8 remaining you can add about here like this. So finally it becomes 0 is nothing but the positive, represent positive. Then 100, 100 is nothing but the second one, that is 8 bit represent exponent. What is exponent here? Exponent here is nothing but the 140 100. 140 100. So remaining is nothing but the remaining is nothing but mantissa. 23 bits are nothing but the mantissa. But here how many bits are there? 3 zeros 1, 3 zeros 1 is there. 3 zeros 1, 3 zeros 1 is there. So remaining you have to put about the 0 zeros. Now introduction to the C language. Explain about background of C language. C was developed by Dennis Rich in 1972. The history is given below. Programming language, development year, developer by. Programming language, algorithmic language. BCPL, Basic Combined Programming Language. B language, Traditional C language. ARC language. ANSI C language. ANSI ISO C language. It is developed in 1960. It is developed in 1967. B is 1970. Traditional C is 72. KR C is nothing but the 1978. ANSI C is 89. And finally ISO C is 1990. So 1960 developed by international group. Second one Martin Richards. Third one Ken Thompson. Fourth one Dennis Rich. Kernighan Rich. ANSI committee ISO committee. Okay. C language useful for machine language as well as high level language. So user can use C language to do about system programming as well as application programming. So C is also called as a middle level language. Now explain the structure of a C program with an example. It consists of the following sections. That is number one, document section. It consists of set of comment lines. These comment lines is required to improve the readability of the program. The lines beginning with slash star and ending with the star slash are known as block command for a single line. The line starts with two slashes is called line comment. It cannot read by the compiler. Second one, link section. The link section link functions from system library using hash include directive. Definition section. The definition section defines all symbolic constants using as defined directive. Global declaration section. There are some variables that are used in more than one function. They are called as a global variables. These variables are called global variables and are declared in the outside the all functions. Then main function. Every C program must have only one main function section. This section consists of two parts, declaration part and executable part. These two parts must appear between opening brace and ending brace. Opening brace and ending brace. Subprogram section. The subprogram section. The subprogram section contains all the user-defined functions. User-defined functions are written either before or after main function, but generally written immediately after main function. So these user-defined functions are called main function. The example program just read about ABR value, Enter AB values, R equal to A plus B, print about its sum R. Explain about the main function we see with example. The main function consists of two parts, declaration part and executive part. Declaration part and executive part. And main function also written about the int main or void main. If write int main there is written 0, if write void main there is no written 0. These two parts must appear between opening brace and closing brace. Declaration part contains declaration statement. Executable part contains executable statements. Declaration statements are variables and constants, but executable statements are scanf, printf, if, while, do while, etc. The all statements in declaration and executable part end with a semicolon. The execution of program starts from main function. Every C program must have only one main function, and this function is written as follows. Main is like this: AB values, read scan AB value R equal to A plus B. Then you put about the type about the sum value is R. So finally it will display about the sum value. What are the comments used in C? Explain with an example. Already we explained this one. The lines beginning with slash star and ending with star slash are known as block command. For a single line, starts with two slashes is called line comment. This comment line cannot be read by the compiler. Comment lines cannot read by the compiler. These comment lines improve readability and understandability of the program. The example program is given by hash include stdio.h into main. Float ABR because ABR have three variables declared here. Enter AB values, read these AB values here. R equal to A plus B. Sum find sum. Then the sum is print the result. Okay, what is the value? Now, what is an algorithm? Explain with an example. Algorithm is step-by-step process or sequence of steps for solving a problem. Each step should be well defined. It can be divided into three types. Sequence. In an algorithm, if all steps are shown, then it is known as sequence. For example, an algorithm for adding two values, start, read AB, R equal to A plus B, print or stop. Selection. Here we use if condition and the condition is checked only one time. If a condition is satisfied, the next statement is executed, otherwise else statement is executed. For example, an algorithm to check whether the given number is given or not. Start read n. If n percentage equal to 0, go to step 4. Otherwise go to step 6. If it goes step 4, then even number it going to print, else it going to be print about odd number. Then iteration, here we use while, do while and for. And the condition is checked a number of times. The statements in an iteration block are executed number of times based on some condition, that is actual definition. For example, an algorithm to print 1 to n numbers using while loop is given by step 1 start, step 2 read n, step 3 initialize I equal to 1. Step 4 while I less than or equal to go to step 5, otherwise go to step 7. So step 5 means print I, then compute I plus plus increment, give increment, then go to 4 till the condition going to be failed. So it's going to print continuously. Then what is flowchart? What are the symbols used in flowchart? Explain with examples. Flowchart is a pictorial or graphical representation of the sequences of steps. Graphical representation of sequence of steps for solving a problem. Flowchart uses different symbols. It consists of start and stop symbol. One is start and stop symbol. Start is beginning of the flowchart. Stop is ending of the flowchart. The general symbol used is this one. The example this one. It is used outputs input output symbol parallelogram. Remember, one is read A comma B. Second one is print A comma B. Initialization process is nothing but rectangle. In rectangle, you can write about the initialization or you can write about the computation. Decision symbol is a diamond shape. So there are two cases, false case and return true case. If n percentage 2 equal to 0 true case, it comes like this, false case it goes to like this. The loop symbol, number of times condition checking is called a loop. The general symbol for loop is hexagon like this. Only the difference for decision and this one is here, true, false is there, but there is no repetition here. Here repetition is there. It is used for three types of loop. They are while loop, do while loop, and for loops. It follows initialization condition in increment or decrement. The example is given below. This example. Just I equal 0 while I less than or equal to print I. Then it goes to increment or decrement and it goes to checking the condition again. Like that continuously check the condition. If condition fail, it comes to like this. Connector symbol. The general symbol for connector symbol is circle. It is used to establish a connection or joining of two or more parts. It represents the following. Joining from previous block this one. What are identifiers are variables? What are the different rules used? To identify data and objects in program we use identifiers. To store data value a variable is used. What are the different rules? First one is nothing but the first character in the name should be alphabet or underscore but not digit, first letter. The other characters may be alphabet, digits, and underscore. Names should not contain blank spaces and hyphens. Names cannot be keyword. Uppercase and lowercase are different names. For example, the valid identifies so and so, invalid identifies as so and so. How to declare and initialize variables in C? After designing suitable variable names, we must declare them to the compiler. Variables are declared at the declaration part only. The declaration part is specified at the beginning of the program. Declaring variables with a semicolon at the end is called declaration statements. The syntax for declaring a variable is as follows: type data type variable 1, variable 2, data dash variable 11, where variable 1, variable 2, variable 11 are variable names. Example: int abc, int width, comma height. Variable declared can be initialized using an assignment operator equal to. We can do declaration and initialization in separate line. The syntax given by like this. Otherwise, we can do declaration and initialization in the same line. The syntax is given by data type variable equal to value. Int b equal 20. Explain about different types of data types in C with examples. The different data types are integer, floating point, character, and boolean types. They are integer types. Integers are whole numbers. It can be different types. They are int, unsigned int, short int, long int, unsigned short int, unsigned long int. Floating point types. Floating point numbers are real or fractional numbers. It can be two types. They are float and double. The float is single precision and while double is double precision number. There is one more type is known as long double. See here int unsigned int size of bytes is 2 but values are nothing but minus 32,768 plus 3267. But at the in between 0 is there, that's why in unsigned int add these both values 0 to 6535. Now percentage u is nothing but conversion character. Similarly short int, similarly unsigned long int. Float e means exponent, e means into 3.4 into 10 power minus 38. That is the meaning of e minus 38. Okay. Then float double, long double. This value you have to remember. It's called conversion character. It is called. Then char unsigned char. Char means minus 128 to 127. Unsigned char means 0 to 255. Character types. So a single character can be defined as character type. It can be represented by char. It can be two types. They are char and unsigned char. Specifying group of characters in double quotations is called a string. String is represented by character array. For example, array equal to value is called string. Boolean type. A Boolean type takes only two values, true or false. Here we use keyboard bool. In integer, Boolean values are true 1, false 0, like that. Okay, what are different types of constants in C? Explain with examples. Constants in C are fixed values that do not change during the execution of the program. It consists of integer constants. There are three types of integers: decimal, octal, hexadecimal. Decimal means 0 to 9, that is, and octal means 0 to 7. Hexadecimal means 0 to 15. 0 to 15. So here decimal integers consist of set of digits from 0 to 9. Octal integers consist of 0 to 7. Hexadecimal integers consist of 0 to 15. But here one of the important one is 10 to 15 represented by capital A to capital F or small a to small f. Examples are nothing but a equal 129, b equal minus 325, into c equal 037 minus 0435, 0x or 0 capital X. These are nothing but the representing about the before 0x, starting from 0x means hexadecimal, starting from 0 means that's the octal value. Floating point constants. Floating point numbers are called real constants or floating point constants. Examples are float g equal to so and so, double h equals so and so. Character constant contains a single character enclosed within a single notation. String constant means it's going to represent in a double quotations. Backslash constants are this one. Backslash a new line character, backslash the horizontal tab, backslash b vertical tab, backslash b backspace. Explain about formatted input and output with examples. Formatted input and output function. We use scanf function for formatted input. The printf function is called formatted output function. Here we use different format specifiers. The different format specifiers are given by percentage d signed decimal, percentage u unsigned decimal, percentage x hexadecimal, percentage o octal, percentage y decimal, octal or hexadecimal, percentage f floating point, percentage e scientific notation, percentage lf double value, percentage g floating point value, percentage c character, percentage s string. To read integer we use the percentage d or percentage u or percentage I specified. To read a floating point number, we use about percentage f or percentage. Similarly, to read octal or hexadecimal, we use percentage o or percentage x. Example is scanf and the percentage a, sorry, and a, where it reads a decimal value and storing variable a, and a represents the address of a. To display a value, we use format specifier, that is printf, the result is percentage a comma 10. That means the result value, how much it's going to print, 10 is going to print. So here percentage matches with integer value 10. That's why print about 10. Explain about unformatted input-output functions with examples. Unformatted input function. It will only work with character data type, that is character or string. It does not require any format specifiers. It uses two input functions, getChar and gets. GetChar read only one character at a time. Gets read characters, number of characters. Unformatted output function. It will only work with character data type. It does not require any format specifiers. It uses two output functions, putChar function and puts function. PutChar function print only one character at a time. Puts can print about many characters. Explain about format modifiers with examples. Format modifiers are used for modifying both printf and scanf. Modifying printf. It can be minimum field width specified. Here an integer is placed after percentage sign. Percentage 05 means how many values, 5 values are required in output, but only 2 values are there. So remaining it will take about 3 values are 0. The precision specifier. Here a float value is placed after percentage sign. Example. Percentage 0.4f specifies its precision specifier is 4. That is float a equal to 15.46. Printf 0.4f means after point how many values are there? 4 values are there. So that's the remaining values you can take about the 2 zeros. 46 only there 2 values, so remaining 2 taken as a 2 zeros. Modifying scanf here, an integer placed after the percentage sign. For example, to read 20 characters into A, we write scanf percentage 20 as comma A. If input is greater than 20 characters, then after 20 characters you cannot read it. For example, if you enter A, B, C, D, F, G, H up to Z, only the first 20 characters are up to T are placed into A. What is scope? What are different types of scope? Explain with examples. A starting brace and ending brace is called a scope. It is a region of the program where a variable can access from that region. Beyond that variable, it cannot be accessed. Local scope. Variables defined within a function have local scope, and variables that are declared inside a function are called local variables. They can be accessed only in that function. In the following program, ABC are called local variables because ABC are defined in main function. Global scope. Variables defined outside a function have global scope, and variables that are declared outside a function are called global variables. Global variables are declared on top of the program. They can be accessed to any function. In the following example, ABC are global scope, global variables. ABC because outside main function, outside I'm defining that's what is called as a global variables. What are different storage classes in C? Explain with examples. A storage class defines the scope and lifetime of variables. The variables which are visible to a function are called scope. How long the variables exist in the storage is called lifetime of variable. There are four storage classes. They are automatic variables. Automatic variables are declared inside a function using auto keyword. Automatic variables are local variables. The syntax is given by auto type variable, that is here inside series write auto int a equal to 100. External variables. External variables are declared anywhere in the program using extend keyword. The external variables are global variables. The syntax is given by extend type variable, that is here extend int a, here you can initialize it. Then static variables. Variables declared as static are known as permanent variables. It can be two types, static local variable, then static global variable. When we apply the static to a local variable, then that variable is called static local variable. The syntax is given by static int variable, a static type variable. The example is given by int series static int a equal to 100, a equals so and so return a. This is called as a static. In the program, in the above program, when you call function, then a equal to 122. And second time the function is called, then a equal to 146. Like that it will increase. Similarly, static global variables. When we apply global variable as a static, then that variable is called static global variables. The syntax is given by static int a equal to 100 outside of the function static int a. In the above program, when you call a function, then a is 123. Then second time the function is called, then a equal to 146. Like that, it continuously going to be increasing. Register. Normal cases it cannot increase, just only in static case only it increases. Register variables. Generally, normal variables are stored in memory. To process this variable, we need to access this variable from memory and then process. This takes more time. The register variables are in CPU, so no need to access this variable from memory. So example is given by int series register a equal to int a equal to 100, a equal to a plus 23 written a. Explain about type qualifier in C with examples. In C, a type qualifier is a keyword that is applied to a data type. There are two types of qualifiers. One is constant keyword, second one is volatile keyword. If the variable value does not change in the program, then we use const keyword. The syntax is const data type variable name. The example is given by hash include stdio.h. Int main constant a equal to 10, print a, change a value and then print a. But it gives error because const cannot going to be changed. The value, volatile keyword. By declaring variable volatile, compiler come to know that this variable can be changed at any point of at any point of time this variable can be changed. The syntax is volatile data type variable name. Example is given by hash include stdio.h int main volatile int a equal 10, print a equal to 100, then print a return 0. Now explain about expressions in C. An expression is a sequence of operands and operators that reduces to a single value. Expressions can be simple or complex. A simple expression contains only one operator. For example, 2 plus 5 is a simple expression whose value is 7. A complex expression contains more than the operator. For example, 2 plus 5 into 7 is a complex expression whose value is 37. Primary expressions, different types. Postfix expressions. Primary expressions A, B12 are primary expressions. Postfix expression it A equal to A plus plus, A minus minus. A plus plus means first it going to store A, then it will take increment. A minus minus means first it going to be store here, then next it going to be increment. Here, first it going to be increment, then it going to be stored. It going to be decrement, then it going to be stored. So, postfix expression means a postfix expression consists of one operand followed by one operator. One operand, one operator. Plus plus minus minus will give us postfix operator. Prefix operation also same. Plus plus and minus minus. Unary operator. Unary operator is nothing but is a prefix expression consists of one operator followed by one operator. There are three types of unary operators. They are increment, decrement, not operator. Okay, not operator. The different examples are given. Binary expressions. Binary expressions are made in the form of operand, operator, operand combination. Any two numbers added, subtracted, multiplied, or divided are included in binary expression. Explain about precedence and associativity in C with an example. Each operator in C has a precedence associated with it. This precedence is used. This precedence is used to evaluate an expression having more than one operator. So here see bracket first evaluation, next this one, next this one. So first preference is given this, second preference is given this. Okay. There are different levels of precedence. The operators at higher level precedence are evaluated first, lower level precedence are evaluated next. High level precedence and low level precedence. The operators of the same level of the precedence are evaluated from left to right or right to left, depending upon the level. This is known as associative operator of an associative property of an operator. For example, star, slash, percentage having same level of precedence. In this case, we consider the order from left to right. The operator precedence and associativity is shown in the above figure. For example, consider the following example: a equal to 9, b equal to 4, x equal to a plus b into 2 minus 1. That is, substitute a value, b value, you get 25. What is side effect in C? What is side effect in C? An action that comes from the evaluation of an expression is called side effect. Expression without side effects. If expressions have no side effects, then the values of all its variables are unchanged. Okay, for example, consider the expression a into 4 so and so. Substitute a value, b value, c value, get about one answer. Expression with side effects. Consider the expression minus minus a star 3 plus b by 2 minus c plus plus star b. Then the expression becomes minus minus 3 star minus 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 3 star 3 plus 4 3 plus 4 by star 2 minus 5 plus plus star 4. Here, what is the value? 2 into 7 by 2 into 7 by 2 minus minus 3 means change the value as 2. into 7 3 plus 4 by 2 minus 5 by 2 by 2 minus 5. So by 2 here it is there, by minus 5 is there. Then next one is nothing but the continuation. Okay. What is type conversion? What are different types? Explain with an example. Conversion, type conversion. Implicit type conversion. If the operands are of different type, if the operations are different types, the lower type is automatically converted into local type, higher type before the operation. If the result is of the higher type, it is called implicit type conversion. In an expression, the sequence of rules for evaluating expressions are number one, if none of the operand is long double, then the remaining will be converted into long double and the result will be long double. If one of the operand is double, then the remaining will be converted into double and the result will be double. If one of the operand is float, then the remaining will be float and next one. Next, if one of the operand is unsigned long, then a long int, then unsigned int. So likewise, we can add these values to get about the 33.5. So we can take our same example. Then explicit type conversion, that is also called as a casting. If automatic type conversion is not possible, then we go for casting a value. Converting higher type into lower type is called explicit type conversion. See x equal to 5 into 21.5. All 21 points are converted into integers. Double sum by n. First sum by n is calculated in terms of points. Then we are converting it to double. Likewise this one. Okay. Here also same thing. Float c by d means first within first c by d going to work. What is the c by d value? C by d. C1 d is 2. So 1 by 2. 1 by 2. Value is 1 by 2. So that means 10 by 20. 0.5 plus 3.5. Add all this. Then add about the point 0.5. So then we're getting about this answer. In the above example, the C by D is a high integer value, so it is casted into float. Now the expression A comma B are integers and remaining are float. So AB are converted into float, and the result is also float. Now the result is R equal to 33.0. The statements in C. What are its different types? Explain. A statement causes an action to be performed by the program. There are three types of statements. They are null statement. The null statement is just a semicolon as shown below. Semicolon, just a semicolon. An expression statement. An expression statement is an expression by placing a semicolon. Semicolon. And then it is a semicolon expression. Return statement. The return statement terminates a function. When there is no return statement at the end of the function, then it can be void. Then what are command line arguments in C? Explain with an example. At the command line, at execution, passing arguments is called command line arguments. To pass command line arguments, first define main with the two arguments. First argument is the number of command line arguments and second line is the list of command line arguments. X is greater than or equal to for I equal to I less than x I plus plus printf AI. So first you go into execution type slash a dot out here hello space world you type. Then it's going to be taken hello world starting and it's going to be printed here. And here this is nothing but program mistake, that is slash dot dot slash a dot out hello world. Okay, it is correct. So in this case, just what you have to do here means first argument is the number of command line arguments. First argument is the number of command line arguments, and second is list of command line arguments. First argument is the number of command line arguments, and second is list of command line arguments. Okay, here slash a dot out space hello world is display dot slash a dot out hello world. Okay, hello world. So it's going to be completed about the first unit in simple format.